Hello all, welcome to the next important lecture of this course. In this lecture, we shall see how to do CFD analysis for a wind turbine blade. Here we are given with the input CAD model of a wind turbine, and from that CAD model we will create CFD domains, apply the boundary condition and solve the case in CFX solver. This is the specification of the given wind turbine. It has got a rotor diameter of 64 meter and a rated wind speed of 15 meter per second, and the tip speed ratio for this case is 8. Therefore, the tip speed is 120 meter per second. The RPM for this turbine is 35.8 and the max chord is 3.2 meter. Let us see what is the power available for this particular wind turbine. The wind power is given by half rho A V cube, and the theoretical power which can be extracted from this wind turbine is given by 16 by 27 into wind power, that is based on the Betz limit. You can check some material on the wind turbine power calculation so that it will be easy for you to understand these calculations. So this theoretical power will be roughly 59.3% of the wind power, that is 16 by 27 of the wind power. For this particular analysis, we will take standard atmosphere conditions. So the density will be 1.225 kg per meter cubed, and the area of the rotor is given by pi by 4 into 64 square meter square, and the velocity is 15 meter per second. So using this formula, we got the wind power of 6.65 megawatt, and the theoretical power which can be extracted from the wind is 3.94 megawatt. This is the maximum power which can be extracted for this given condition. So after the analysis, we shall see what is the power output from this turbine, and we can calculate the efficiency of this turbine. Coming to CFD domains, for modeling this wind turbine in CFD, we have to create two domains. One is this outer stationary domain, and another one is the inner rotating domain. So this inner cylinder is the rotating part and the outer cuboid is the stationary part, and it has got an interface region which is common for outer stationary domain as well as inner rotating domain. So we have to specify this interface region to simulate this wind turbine. Here you can see the outer stationary domain without the inner blades and the inner rotating domain with the blades. We may have to split the domain at this region near the shaft location, so that the left part of this will become rotating domain till the turbine vicinity, and the remaining part will become stationary domain. And this is the workflow in Ansys CFX for this particular case. Here we are given with a CAD model input, that is a parasolid file. windturbine.x_t is the parasolid file which is given, from which we will create fluid domain in Ansys workbench. So from this CAD input, we will create CFD domain in Ansys design modeler and do the meshing in Ansys workbench. So after doing the meshing, we will specify the boundary condition in CFX preprocessor and solve the case in CFX solver. Now let us go back to Ansys workbench. In the analysis systems, let us use fluid flow CFX. Here geometry, mesh, setup, solutions and results are present in a single window. So we shall right click geometry and then choose new design modeler geometry. Here let us import the CAD model of the wind turbine. Go to file, import external geometry file, and choose this windturbine.x_t. This is a parasolid format. It is a neutral format like STEP or IGS. You can right click import and click generate. Now the wind turbine model is imported here. Here you can see the turbine rotor along with the support structure. Now let us create the outer stationary domain and inner rotating domain in design modeler. First, let us select the plane ZX. Here we shall draw a sketch for the outer domain. You can click this negative y direction so that you can see in a perpendicular frame. Choose rectangle here and draw a rectangle around this turbine. Now let us specify the dimensions. Choose length, select this vertical distance or vertical lines, enter the value of 150 meters for this horizontal distance. Choose length again, select the mid section and the right side line and enter 75 meters. Similarly, let us specify the heights for vertical distance. Let this be 100 meter. In the last dimension, let it be 45 meters. So that now the base of the support structure and the domain bottom face will be matching. Now come to modeling. Now we shall extrude this geometry. Click extrude and select this sketch. Click apply. Now let the distance be 200 meters in total. but let us keep 150 meters downstream of the turbine and 150 meters upstream of the turbine. Let us maximize this. Go to direction, choose both asymmetric. So in the one side it will be having 150 meter and in the upstream it will be having 50 meters. Right click, generate. Now we have generated the outer domain. So here if you see the part bodies, there will be two parts. One is the outer domain and one is the imported structure. So in the outer domain we shall change this to fluid and let us rename to outer domain. We can hide this and we can rename this to turbine solid. Now let us hide this and create the inner domain. Let us create the inner domain till the end of this turbine shaft. We shall create a plane in the center between these two faces and we shall separate the inner and outer domain. Click ZX plane, right click and then go to create new plane. So here you can choose the base plane as ZX plane and transform will be offset Z. We have to specify the offset distance here, 3.5 meters. Right click and generate. Now we have created a plane at this center location. Now click this plane and go to sketch and click this minus y direction. Let us draw a circle to create the inner domain. Draw a circle with origin as the center and let us specify the diameter of this circle as 70 meter. The rotor tip diameter 64 meter. So we shall create slightly bigger size domain. Now come back. So after creating the sketch, let us extrude the inner domain. Click extrude and then select the sketch created. Apply. Let us extrude by 8 meters in the reversed direction. Then only it will be covering the entire blade rotor. Before that we have to choose add frozen. If you choose add material, then it will be merged with this existing outer domain. So you have to choose add frozen and generate. Then it will create a separate component here or separate part here. So this is the inner domain. We can specify rotor domain. Now we have to subtract the turbine solid from both this outer domain and rotor domain. Next is the important step. We have to use Boolean operation to remove the solid portion from this fluid domains. So go to create, choose Boolean. Here choose subtract option and the target body will be the outer domain. Let us subtract the cylinder from the outer domain and then we will subtract the solid from the outer domain. So first let the tool body be rotor domain. Click apply. Here it is asking for whether to preserve the tool body. Click yes. Now you can right click and generate. Now it has created the outer domain without this cylinder. You can show this body and you can hide these two bodies and you can use cut plane. This is called section plane. You can draw a line around the center and you can see now it has removed the center cylinder from the outer domain. Let me hide this. In the next step we have to subtract the support structure and turbine from this outer domain. So go to create Boolean, select this outer domain in the target body and then in the tool you have to select the turbine solid. Click apply. Preserve tool bodies, you have to choose yes because we have to use this turbine solid to turbine rotor from the inner domain. Now right click and click generate. Now we shall see the sketching plane. Now we can see the inner domain as well as the support frame is removed from this outer domain. In the last step we have to remove the turbine solid from the inner domain. Go to create Boolean, choose subtract. In the target body choose the rotor domain, click apply. In the tool body you have to choose turbine solid. Now you can choose no for the preserving tool body option, because now henceforth the solid model is not required. So you can choose no and right click and generate. Now the solid portion is gone and only outer domain and inner domain are present. You can choose show body here. You can see the outer domain, height body, and the rotor domain, height body, show body. You can see the inner domain with the hollow region in the place where blades were present. Show all bodies. We can delete the section planes. Now outer domain and inner domain are ready. We shall create the mesh for this and specify the boundary conditions in CFX.